This video will deconstruct the Georgia Standards of Excellence 2 NBT1, which focuses on understanding place value. 2 NBT1 states that students will understand that the 3 digits of a 3-digit number represent amounts of hundreds, tens, and ones. They will understand the following as special cases. 100 can be thought of as a bundle of 10 tens, called 100, and the numbers 100 through 900 refer to the number of hundreds with 0 tens and 0 ones. Kindergarten students begin place value understanding by composing and decomposing teen numbers into 10 ones and some more ones. First graders then transition to understanding that 10 ones equals a bundle of 10 and that the 2 digits of a 2-digit number represent amounts of tens and ones. Place value understanding is the critical building block for reading and writing numbers, comparing numbers, addition and subtraction of larger numbers, multiplication and division, as well as understanding decimals, which are skills that are addressed throughout elementary. Students in kindergarten and first grade should use groupable manipulatives such as Lincoln cubes, counters, and sticks that can be bundled and unbundled as they compose and decompose numbers. Second grade students then transition to pre-group base 10 models such as base 10 blocks and printed 10 frame cards. It is important that students first use concrete hands-on tools before transitioning to representational models. Representation should progress from proportional to non-proportional models before moving to the abstract. True place value understanding takes time. Second grade students should have ample opportunities to explore concrete manipulatives before transitioning to representational models and abstract numerical representations. The acquisition of numeracy occurs in developmental stages. Students begin with a unitary or counting by ones concept of numbers. Students then begin to group ones and begin to see a 10-structured system of counting. This thinking progresses into deeper place value understanding where units of tens and ones are counted separately and can be traded or exchanged, which then leads students to understanding multi-unit concepts that extend beyond tens and ones. To deepen place value understanding, students can play Race to 100 by using a variety of base 10 models and representations. Students simply roll a die and add that many counters to the ones place. They then regroup their counters until they have 10 tens or 100. So when you add another 10, how many tens will you have?
10 of 10 tens.
10 tens? Yeah. So what do 10 tens make?
100.
100.
Equals 100. 100.
This game can then expand to 1,000 as students begin to build larger numbers. In this next video, you will see how students discovered that adding one block to the ones place created a new 10. 30 tens then equaled 300. So how many ones do we have?
0.
How many tens do we have?
0.
A similar game, triple digit cover-up, can also be played by using base 10 blocks and hundreds charts that go up to 1,000. Students roll the die and either add a flat, rod, or cube to see who can be closest to 1,000 without going over. Closest to 1,000.
Me?
How many do you have?
510.
510. How many did you have?
490.
Student understanding progressed and became more strategic after playing multiple times. Only using tens and ones didn't get them very close to 1,000, but using hundreds along with the tens and ones did. The value of each digit was reinforced as students strove to get the closest to 1,000 without going over. To reinforce the value of each digit in 2- and 3-digit numbers, I Spy a Number, found in the Georgia frameworks, can be used as a regular classroom routine. The upcoming video shows a group of second graders trying to guess a specific mystery number. As students made guesses, they were told how many digits and places in their number were correct.
82.
Does he have any digits correct? One digit. and it's in the right place. Okay, call on someone else.
58.
What digit would be correct? 8. But is it in the right place anymore? Okay.
Do we know what's in the 80s? 80. What? Because 8 has to be in the front.
Where does the 8 need to go?
In the front.
In the front? In the tens place?
It's in the 80s. That means we know it's in the 80s.
Okay.
No, it's 89. What a number. 2.
So her mystery number was 89. We have 2 digits correct and 2 in the correct place. In this framework task, students compose numbers in different ways by making base 10 pictures. After building their pictures, they determine the number of hundreds, tens, and ones that were used. This task encouraged students to see that numbers can be represented in different ways. Not only did they enjoy sharing their designs, they enjoyed seeing whose robot had the greatest value. Understanding the value of each digit and that numbers can be represented in different ways lays the critical foundation for the flexible thinking that is needed when working with numbers. For example, 124 is more than just 100, 2 tens, and 4 ones. It can be represented in a variety of ways that all show the same quantity. In the upcoming videos, students will build 147 in different ways. How did you create 147 a different way?
We did 10 tens, 10 tens, and 7 ones.
So you have 14 tens and 7 ones.
14 tens.
14 tens. Does 14 tens equal 140?
Another way. And makes 140.
Yes.
I broke up one of the tens into one, so I have more ones, and then I used 3 tens and 100.
So you have 100, 3 tens, and how many ones?
17.
17 ones. What Number Am I is another great classroom routine that helps develop base 10 understanding. How do you know that 3 hundreds, 12 tens, and 5 ones is 425?
I know that by like 300, but there's 10 tens, so 10 tens is 100. So I put 400 down to add 100, and then I know there's 2 tens left, so I put 2 tens, and then it says 5 ones, so I put 5 ones, so it's 425.
How did you know that 2 hundreds, 32 tens, and 21 ones was 541?
300 plus 200 equals 500. Bring it down here. Then plus 20 equals 520. Then 520 down here plus 20 equals 540. 540 plus 1 equals 541.
To support instruction, there are several connections to literature that bring place value understanding to life. In Circumference and All the King's Tens, the Queen wants to have a party for the King. So many guests began to arrive that they lost count and began to organize the crowd into groups of 10. Eventually, 9,999 guests arrived. Organizing the attendees into groups of ones, tens, hundreds, and thousands helped keep track of the total number of guests. Even though the digits were the same, the placement of the digits determined their value. In a place for 0, count infinity formed a new digit, but 0 meant nothing, and no one knew what his job would be. The king declared that no more zeros would be made until they found a purpose for this one. The count soon discovered the additive property of 0. He could add 0 plus 1 to make a new 1. The 9 digits also discovered that counting could go beyond 9. When 2 digits stood beside each other, they made lots of new numbers, which showed that everyone had a place and value. For additional activities and resources, please visit Unit 1 in the Georgia Frameworks.